So, discovered by Arno, Penzias, and Robert Wilson in 1965, this signal provided landmark evidence for the Big Bang. While the CMB appears extremely smooth, the same in all directions, to about 1 part in 100,000. Quite smooth, because even smoothness has a measure to it, right? Sensitive instruments have detected tiny temperature variations, imprints of primordial density fluctuations in the early universe. So there are tiny little overdensities that are of very much interest to us at the end of the day, because these are actually responsible for why we are here, because these are responsible for how the first galaxies came to be, how the first stars, and how us came to be eventually. Okay, so we're talking about an early time in the universe when there were no galaxies, no stars, no nothing. And of course, we come from stars that have died and spewed all their material into the interstellar medium to make gas, nebula, stuff like that, which are later on condensated to make something like our sun and the planets in our own solar system. Okay, so it's extremely interesting, intriguing, and informative to look back at a time that is so early indeed in the universe, where we can take help from these photons that are still hanging out. And the signature is smooth in all directions, isotropic, homogeneous, with just tiny little non-homogeneities, which we call these overdensities or little temperature variations or fluctuations, okay? So these slight irregularities are the acoustic signatures of the early universe, traces of sound waves that rippled through the hot plasma of the young cosmos. By studying these patterns, scientists can learn about the universe's composition, shape, and how it has evolved over time. Okay, so then we actually went on and talked about the acoustic signatures, which are in the previous live stream. So if you go to my channel and look under the live tab of the channel, you will see all the different live streams recorded there already. And last week, or the last live stream that we did, we already talked about the acoustic signatures. So I want to move on from there after that brief introduction and tell you about observing this early universe with COBE, WMAP, and Planck. So of course, Planck, you know the name, but it is also the name of an experiment, an observatory, satellite, whatever, named after the person, obviously. Ryan, you're back. Well, we're just about to talk about the observing of the early universe. Can we get 30 likes? Comparison of cosmic microwave background anisotropy maps. So at this point in the lecture, we have accepted that there are these tiny little anisotropies, even though the cosmic microwave background radiation is largely very isotropic, very homogeneous.